Okay, guys, today we're talking about proving the leg formula for the law of cosines. Okay, so I have a general triangle here with my capital letters representing my angles, lowercase letters representing my legs. And I'm trying to find the distance of A. Okay, well, with triangles, we know the first or the most popular formula for leg length or angles or anything like that is the law, or I'm sorry, not the law, but the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. That's very popular. So what I can do with this triangle is I can drop a perpendicular, okay? This triangle may look a little skewed where this angle doesn't look 90, but we'll just say, for safe's sake, that it is. And anyway, when you take an SAT or ACT question, they'll always say not drawn to scale or anything like that, just to try to throw you off. So we're going to assume that this is 90 degrees. And since we're talking about leg A, I'm going to look at angle A because we know the leg length is also proportional to the angle size. Okay, so the length of little a is actually proportionate to the size of angle A. So now I look at my basic trig functions like sine and cosine. And we're talking about angle A with this new triangle. When I say this new triangle, I'm talking about from A to B to this point right here. It doesn't really matter what we call it. But I can call this length right here. I can call this length X. Okay? And I'll call the perpendicular that I drop, I'll call it H, representing the height. Okay? So now I'm going to look at the sine ratio of angle A. Well, sine is opposite over hypotenuse. So the opposite of angle A is my opposite, which is this height right here, which is going to be H, over the hypotenuse of this triangle, which is C. So the sine of angle A is H over C. Now let's find the cosine of angle A. Well, cosine is adjacent over hypotenuse. So adjacent to angle A would be X. And then the hypotenuse would also be C. Okay? So I want to solve for X and H. Okay, so if I want to solve for X and H, I want to get H right here by itself, so I can multiply both sides by C. Same for X, multiply both sides by C. Now I have C sine, C times sine, we'll call it theta, equals H, and C times cosine theta equals X. So now I know what X is and I know what H is. Okay, now that I know what H is, let's find out this leg right here from B to C. We're going to call that B minus X because of this entire length from A to C, if that is little b, and I named this said length over here, if I named it X, this would just be what's left over, B minus X. So now I can find the actual length of A using the Pythagorean theorem, which is A squared plus B squared equals C squared. So in this little case, this B minus X could be my A, the H could be my B, and then A is my C. We're going back to the more elementary letters using the Pythagorean theorem. So let's plug them in. For A squared, I have H minus X. I'm sorry, that is B minus X squared plus B squared, where we said that the H would represent our B, equals the C squared, and that is where we have our A. Now, I have X's and H. Well, I already know what X's and H are. They're over here. But I need to simplify this binomial first before I can plug in my values of H and X. So when I do that, that is just b minus x times b minus x. So we need to distribute here. That's going to leave me with b squared minus b times x minus x times b plus x squared. Now I have like term. Well, let me go ahead and bring down everything else. Plus the h squared equals a squared. Now I have like terms right here. So I need to combine my like terms. So I have b squared. When I have two like terms right here, even though the letters are in opposite places, order doesn't matter. So I actually have negative 2. I'll call it bx plus x squared plus h squared equals a squared. Okay? Now I'm going to plug in my values for x and h because I have them right over here. Okay? So now I have b squared minus 2bx. Well, I know x is the same thing as c times cosine of theta plus x squared. So I'm just going to write c times cosine theta squared plus h squared. I know h is c times sine theta squared. All of this equals a squared. Now I can just do basic laws of algebra and simplify this a little bit. So I have b squared minus this 2b times c. This c is staying with the cosine because they're multiplying. So this is just going to be 2bc cosine theta. Okay, the actual formula should be coming to light right around here. Plus c squared cosine squared theta, because you have to take this exponent and distribute it to both terms inside parentheses. Then plus c squared sine squared theta equals a squared. Same concept applies. Distribute the a squared to both terms on the inside. Now I have c cosine squared and c sine squared. I have a common factor in both of these. I have this c squared that's in common. So I'm going to pull it out. So now I'm going to have b squared minus 2bc cosine theta plus c squared, and in parentheses I'm going to have cosine squared theta plus sine squared theta equals a squared. Let me move this screen up just a little bit so you can follow me. Okay, now going back to the trig identities we've already learned. Cosine squared plus sine squared, we know that is 1. So we can just cross this out because c squared times 1 is just c squared. Now let's arrange what we have left. Remember, we always want exponents going high to low. So we have b squared plus c squared, just going in alphabetical order, minus 2bc times cosine. And then we've been saying theta. We know the angle we have used this entire time has been angle A. Let me put that in parentheses for you. A equals a squared. And there you have it. That is the proof for the leg formula using the law of cosines.